All right, everyone. I think we're going to get started. Hi, I'm Gabe Monroy, the CTO at Deis, and today we're going to be talking about, I have Kubernetes, now what? This question is really at the epicenter of the work we're doing at Deis these days, and I'm really excited to share a lot of what we've learned over the last few months working with enterprises in the midst of this transition. So first, a little bit about me. Yeah, that's me in front of one of the AT&T 6300s I used to work on. I had a bit of an awkward childhood, if you can't tell from that picture, but it did help get me into the software industry. I started my career at Intuit as a senior systems architect, later found myself doing consulting for software companies in New York City. And in 2011, I took some of the what I had learned there and started a company, a platform as a service company that was acquired by Engine Yard last year. So, little known fact, I was actually one of the largest external contributors to Docker during its formative months. So if you've ever used things like Docker volumes, Docker bind mounts, things like host config inside the Docker engine, you're welcome to yell at me about that stuff. It was things we needed for early versions of Deis to get that off the ground. Also, as a result of our unique relationship with the good folks who put on this conference, we've also helped work out operational best practices with CoreOS, which is something I spoke about at last year's CoreOS Fest. But first and foremost, the thing to know about me is I'm a consultant. So I love working with customers. I spend most of my time peeking into different environments, trying to learn what works and what doesn't work. And a lot of that comes down to separating patterns from snowflakes and helping apply that to what we do at Deis. So when most people think about Deis, they think of PaaS, right? Yes, we offer a great PaaS solution called Deis Workflow. The rumors are true. You can learn more about that at our booth. I'm not going to be talking about that today, though, because more broadly, what we're focused on is accelerating Kubernetes adoption. And this work generally falls into two buckets. The first is open source software that we find complements Kubernetes. You know, as much as I love the Kubernetes APIs, the truth is that there's this massive gulf between what Kubernetes provides and what software teams actually need to get work done. And so if you think about like CoreOS generally as building a lot of the stuff underneath and up to Kubernetes, we're really focused on building the stuff that goes on top of Kubernetes to help facilitate enterprise adoption. And so what does that mean? Lots of modular open source components that fill in the gaps and make Kubernetes approachable to average software companies. And we'll talk more about that in a bit. The second thing we do is provide support and professional services designed to help companies make the transition to this brave new world of cloud native computing. And the transition isn't easy for most folks, but if you're at a large company, it's especially difficult due to all the reasons it's difficult to work inside of a large company. And so that's most of what we'll be talking about today. What does a successful transition to Kubernetes look like as informed by the work we've done with customers in the field? So this talk is really designed for those of you who are looking to promote Kubernetes inside your org. So who are you in the audience here? I see a lot of you turned up, which is great. So maybe some of you have explored using a PaaS solution off the shelf, but you found out that it wasn't quite flexible enough to meet your needs. Maybe you tried building something custom to make Kubernetes or something like it work inside your org, and then realized that that's just kind of a terrible idea. For lots of reasons. Maybe you realize that Kubernetes really does represent Google's 10 plus years running containers at scale, and you want to benefit from those lessons learned. If my experience is any judge, the folks of you in the audience are probably a DevOps professional or some forward-thinking executive with some operational bias towards what you do, and this talk's really for you guys. So before we jump into the Kubernetes adoption lifecycle, I want to talk about something I call the cloud native operational model. At KubeCon in San Francisco, Joe Beda, the co-creator of Kubernetes, gave a terrific talk called The Operations Dividend. If you haven't checked it out, I recommend you pull it up. In it, he shared a lot of detail about how Google segments their operational responsibilities into three buckets. The bottom layer is infrastructure ops. This is things like racking and stacking gear. Most of this layer is really made obsolete by IaaS. On top of this, you have cluster ops, which is taking that raw compute network storage and tying that into a set of cluster APIs like Borg inside of Google, but Kubernetes for those of us outside of Google. And on top of that, you have application ops, known as SREs inside of the Googleplex, who are focused exclusively on how to operate individual workloads, how to update them, how to monitor them, everything about individual workloads. Seems pretty reasonable, right? It's a nice separation of responsibilities. But I want you to stop for a minute and think about how the operations role sits at most companies today, right? You have, people racking and stacking gear, installing OSs on them, installing, system services, tying those groups of hosts into some notion of, a cluster or something like that, then loading workloads on them, figuring out how to monitor and update those workloads, and hanging a pager around their neck to worry about everything from the availability of the box and the network and everything all the way up to the availability of the app. Too much stuff. I mean, it is just crazy the amount of things that the most operations folk are designed to worry about. And it's interesting because at the end of the day, the challenge around transitioning to cloud native, we find is much more about people and culture than it is about technology. It's like less than 50% about technology. I'd argue it's harder to change the minds of these operations folks than it is developers. You talk to developers, look, they need to start writing smaller units of software that ideally follow 12-factor principles, things like that. But when it comes to operations, introducing Kubernetes should really be accompanied by a reorg of the operational model to look something like this process. And the truth is, as an industry, we're really, really far from that. And so one of our goals is trying to move in that direction. So now, getting into this, we see the milestones in the wild for Kubernetes adoption. They're pretty similar to what you're going to find for most technologies. The thing is, you start with a quick proof of concept. The idea here is to make sure you're not going to look like an idiot when you present it to your boss, right? Then you turn that POC into something more formal, an evaluation that covers your actual business requirements. Moving on from there, if the evaluation is successful, you're going to move on to a dev test environment where you're going to take some low-risk workloads and you're going to trial those out, really get a flavor for the thing. Eventually, you're going to muster up the courage and the political will to push some of those low-risk workloads into production. And lastly, you're going to find yourself in a post-production phase, which where the focus is really going to shift to migrating workloads onto the new platform. And one of the lessons that we found is that folks really radically underestimate the importance of that last phase, the post-production phase. Once you make it in production, it's very easy to just like high-five everyone and be like, yay, we did it, and sort of everyone shifts their attention elsewhere. And that could be a big mistake, and we'll talk more about that in a minute. So we have to start somewhere, right? Step one, proof of concept. The goal here is first and foremost to learn, right? If you don't like what you see, fail fast and move on. If you do like what you see, you can start to prepare the case for proceeding with the work. Now, the beauty of POCs is they can be private, right? If it blows up in your face, no one has to know, be between you. I personally find it's actually fun to talk about failed POCs. Everyone likes to hear about a train wreck and things blowing up in their face. It's kind of interesting. But if you don't want to share, you don't have to share. So for Kubernetes, what this means is you're generally going to start out with a cluster stand-up. And yes, it's possible to do this on a laptop. Don't do that. The goal here is to learn. You're not going to learn a lot by standing up Kubernetes on a laptop. You really need some experience with multiple nodes. I'd say 3 at a minimum. You also need to get a sense for things like the networking model, this IP per pod networking model, which is, for a lot of folks tends to lead to some head scratching, depending on how complex your network environment is. Really need to get a handle on that. Once you can get to kubectl get nodes and list the nodes in your cluster, generally you can say mission accomplished and the cluster stand-up's done. And generally, if unless you're running on a really strange like bare metal environment, this shouldn't take more than a couple hours, right? What I refer to as the POC or the cluster stand-up of the POC. Or if you're using something like Google Container Engine, this can happen as fast as 5 minutes. From here, the focus really needs to be on getting some quick wins, right? So, deploy the guestbook app, deploy a simple Helm chart, maybe a more complex Helm chart, but and I suppose if your workloads are already in containers, you can try and get some of those up and running. But don't spend too much time here trying to port workloads. Again, the idea is to learn and to validate and to make a case, going forward to justify a more serious evaluation. If you're spending more than 2 or 3 days on your POC, that might be fun, but you're wasting your time. You really need to stop and move on and get some buy-in. So once you're armed with the POC cluster, you can move on to and some quick wins. You can move on to step 2 here, which is making a case to your boss or your organization about why you should embark on a serious evaluation of Kubernetes. And you might be asking yourself, well, what's really the difference between a POC and an evaluation? POCs typically run under the radar, maybe some people know, tacit approval, that sort of thing. A true evaluation is a formal process. Two key traits here. The first is you get buy-in from the decision makers who are ultimately going to green light moving into kind of a dev test phase, right? If you don't have buy-in from people, you're doing a POC. This is an experiment. And the second is well-defined exit criteria, well-defined up front, that defines whether you were successful or a failure. It was a success or failure, that evaluation process. And that way, sort of, you can kind of, game the system so that, if you can meet the criteria, you can guarantee that you can move on. And you really should be doing this up front rather than trying to make the case after the fact. So when you bring up this idea about potentially moving to Kubernetes, most folks in management are going to look at you and they're going to go, okay, shiny object syndrome. What new thing do you want to play with now, and how are you going to try and justify it? The question you should be prepared to answer is really why Kubernetes? Because look, let's be frank. Kubernetes is really complicated, right? As with any distributed system, lots of moving pieces. In order to justify all this added complexity, there really needs to be some benefits. Fortunately for you, Google published the Borg paper, and in it, they outlined the three main benefits. They're outlined right here. Now, not everyone is Google, obviously. But if these benefits don't generally apply to your company and you can't describe what other benefits might, then you need to ask yourself whether you actually need the additional complexity of something like Kubernetes. The truth is that most software companies churning out lots of software these days do actually gain a lot and stand to gain a lot from Kubernetes. But be ready for this. So diving into this, at its core, a cluster manager like Kubernetes exists to serve developers. And one big measure of success is the extent to which developers can serve themselves without intervention from an ops team functioning like the adults in the room, right? And one of the things I found is that the tolerance for this kind of developer self-service varies widely across companies. Some companies are gunning to have developers pushing straight into production, in part because they want to hang pagers around the developers' necks, make them take responsibility for service uptime. Other companies don't want developers anywhere near production. And it sort of depends on cultural things, I found, more than the actual workloads, interestingly. But regardless of where you fall on the spectrum, realize that with Kubernetes, you're creating a new experience for developers, whether you intended to or not. So you got to make sure that it's what your organization actually wants. Now, most folks looking at Kubernetes are going to have operations as part of their job portfolio. And if you've ever worked in ops, you'll know that the job is fundamentally about risk management. When systems go down or they don't meet their target objectives, people get angry. Sometimes people get fired. It can be sort of a thankless job in a lot of ways. Whether you're on Metal or public cloud, everything's backed by physical infrastructure, right? Most of that physical infrastructure, they actually publish these things called MTBFs, mean time between failure. And if you think about that, for a second, like the components that are in all this gear that we're all running on, they publish this little thing's probably going to fail in like a year, or whatever that is. So it's not a matter of when this stuff's going to fail, or if it's going to fail. It's a matter of when, right? And if you ever worked in ops, you'll know the answer is usually between 3 and 4 a.m. On a weekend, right? And so if I told you that you could use software like Kubernetes to make the failures in your underlying infrastructure not impact the availability or performance of your workloads, that's a huge benefit, right? You need to be leading with that as you explain this to your organization. Everyone cares about reliability, and Kubernetes offers a great solution here. Not everyone is going to need to scale to tens of thousands of servers, right? But it's fair to say that most teams are going to need some level of scalability, either for future growth or for naturally bursty workloads. And Kubernetes handles scalability on a few levels. First, in terms of cluster capacity, you can increase capacity by adding nodes to the worker pool. Add nodes, you're done. You can actually automate this with auto-scaling groups on public cloud environments with memory and CPU triggers, for instance. The second thing is, as you add capacity to the cluster, the Kubernetes scheduler features soft anti-affinity, which means that it will evenly balance your workload smoothly, spreading services across nodes and across availability zones, really maximizing your availability, even as you increase cluster capacity, which is a really nice feature. And the third thing is at the workload level itself. So you can actually scale workloads running on Kubernetes using things like the horizontal pod autoscaler, which can actually be driven by custom triggers. So you can define custom metrics that will automatically scale your workloads in and out. And that's actually something we're working on at Deis. And to reiterate, 3 big benefits according to the board paper: developer self-service, reliability, scalability. Now, it's your job to prove these things, and you got to make the case for why the business should justify embarking on what they're going to look at as a technical adventure. The format for your proof should be a set of acceptance criteria. Must be able to quickly spin up this kind of workload, must be able to handle these failure modes, very specific, must be able to handle these load spikes for these specific workloads, and other criteria unique to your org. And if you do a good job at defining this acceptance criteria, not only are you going to succeed in moving on to the next phase, but you're actually going to gain the respect of your superiors, and that's going to come in handy as you get later on in the process. So in order for the evaluation to be successful, also, you're going to need to start dealing with real workloads, right? There's no more guestbook apps, right? But that doesn't mean you need to migrate all your workloads and the most critical line of business app, first. There's a lot of things that, frankly, don't belong in Kubernetes right now. Your Oracle database, your legacy ERP, whatever it is. Even things like MySQL cluster, those things might not be a good fit in Kubernetes today, depending on your operational requirements. So to make sure that you're successful here, you want to focus on workloads that are a good fit for Kubernetes as it exists today, not because some features down the road are going to make it possible. Stateless microservices, replicated data stores, batch processing, these are all really good fits today. Really the workload selection is key to stacking the deck in your evaluation and making sure that you're successful with moving forward. So okay, we did it. We completed the successful evaluation. We're even the suits are on board at this point. We're on to dev test, right? So stand up the new dev test cluster. We start migrating workloads over. You're going to find that there's a series of challenges that have to be addressed, and it's important to have solid answers to these challenges before you start looking at production workloads. Unfortunately, the challenges are sufficiently complicated that you can't plan ahead for a lot of them. Some things you just kind of got to learn as you go. Generally speaking, services deployed in a cluster manager like Kubernetes will have 3 techniques for talking to each other. A DNS service is very common, one provided by the cluster manager. Environment variables injected into services via the cluster manager is also common. An externals registry for discovery like Zookeeper is common. It's your job to decide what the standard mechanisms are going to be for in-cluster discovery. There's lots of ways to do this. But there's a lot of challenges here too. For example, environment variables have an ordering problem. If you're using namespace level environment variables, if the service isn't created first, then the environment variables won't be injected into any subsequent services. So there's lots of tricks. DNS, due to the way that DNS resolver code works, you got to make sure that it's going to work for your individual workloads. So you're going to want to try a lot of this out. The point here is to make sure you understand the benefits and trade-offs of the different models before you start promoting what's going to work best in your environment. Now, it's one thing for services to be able to talk to each other within the cluster. Totally different game, getting those services exposed at the edge, the internet, so to speak, full of bad actors, open SSL, 0 days, lots of scary stuff, right? Edge routing presents some pretty unique challenges. External DNS, for your public services, you're going to have to get external DNS mapped to some hosts in your edge router. Running edge routing on every node in the cluster is not generally very practical, so you're going to want to pick a semi-static group of boxes. This is kind of an interesting challenge. TLS termination, I'm really looking forward to the future where payloads are encrypted sort of end-to-end inside the cluster. For those of us living in the real world where load balancing requires looking at headers and payloads to actually determine how you load balance, you're going to have to unwrap TLS at the edge. And how you do that is sort of interesting. We offer a unique solution called the Deis router, which is totally modular and powered by Nginx to do this. You should check that out. Origin tracking. For example, Google Container Engine doesn't support proxy protocol. So if you're doing anything interesting on the load balancing side, you might lose track of your origin IP addresses, and you want to make sure you have that sorted out. So anyway, there's a lot of stuff to worry about here with regard to edge routing. Next is manifest management. Kubernetes is driven by manifest files submitted to the API server. Manifests are written in YAML or JSON. Over time, you're going to wind up with a pile of these things. So how do you manage this flood, right? You're going to generally have some generic manifests that probably you're going to want to manage alongside your workloads in version control. And then you're going to have deployment-specific manifests, and you're going to want to keep those in kind of a private ops-only repository. Secrets, obviously, don't go into version control here. They provide a whole other management problem. But again, this is something we're working on at Deis, but you need to be prepared for this, and chances are you're not going to be smiling like that guy in the picture, because this is kind of a pretty hard problem. If you ever worked in ops for a while, you probably have a decent handle on how CI works. Kubernetes makes this actually a lot easier. Things like the deployments API allow you to patch to do rolling updates. You can get into some tricky scenarios where a workload, if the workload changes, if you need to add a replica set or remove a replica set from a workload, that can be a little tricky to manage in the real world. But as long as your CI system has a way to interact with like groups of manifests, you'll generally be okay, and then you kind of rinse, wash, repeat as you stand up CI pipelines for stuff. You may be asking yourself, well, why are we hanging like something like Jenkins or some legacy CI system off the side of Kubernetes like a colostomy bag? If you're like me, you're asking that question. You have all this compute for a build farm, but that's another problem, and again, something we're working on at Deis. I love this quote: modern applications are sufficiently complicated that they need to be flown by the instruments. That's from our chief architect, Jason Hansen. I mean, he's right. If you ever manage applications in production, especially at scale, you'll know how important telemetry is to the operation story. Figuring out your monitoring, logging, and alerting is something you need to do before you get to production. Looking ahead, I see a future where applications are truly fly-by-wire. Canary deployments happen automatically based on VCS changes. Individual canaries are promoted automatically if everything works out well. If service level objectives aren't met, rollbacks happen automatically. This is the kind of future we're looking at, but it doesn't work if you didn't instrument your workloads properly. So you need to make sure you're thinking that through ahead of time. Step 4, production. You figured it all out. Service discovery, edge routing are all nailed. You're managing Kubernetes manifests in VCS like a pro at this point. CI pipelines humming, monitoring telemetry going. You're good to go, right? At this point, you're going to want to stop, take a deep look at the infrastructure, and make sure the topology is exactly what you want going forward. What does your control plane look like? How many hosts are in your data plane? Is it auto-scaling? Do you want it to be? How are you going to connect to your external load balancers, depending on your environment? This stuff isn't easy to change once you're in production, so take some time to plan it out before you do your production cluster stand-up. And I'd argue if you can't go from 0 to production-grade Kubernetes cluster in under 30 minutes, you're probably not ready for production. Upgrades, right? Kubernetes is designed to be upgraded in place. Most of you are probably, who are playing with Kubernetes now, are probably tearing down and recreating your clusters every few weeks. If I'm correct in what I've seen. That's great in dev test. In production, that's not going to be possible. So make sure you understand how exactly you're going to upgrade that production cluster. And most importantly, this is a big question we get from a lot of folks, and a big challenge is, does an upgrade affect the availability of workloads running on the cluster? A lot of people can take a Kubernetes control plane outage. They don't care if kubectl doesn't work for 30 seconds, right? If the workloads running in Kubernetes go down, people care a lot. And so make sure you've actually run through this process. And if you haven't done that a few times, you're probably, again, not ready for production. Security. In the world of containers and distributed systems, security is kind of a mixed bag, right? So on the one hand, you have developers building containers that run as root, using outdated libraries that are full of CVEs. Meanwhile, network security is a total tire fire. Once you're inside the cluster, everything talks to everything else. So something one of our core engineers refer to as mullet TLS. It's like security in the front and party in the back is how most clusters work. I like that a lot. On the other hand, the security story for Kubernetes is actually getting a lot better in the near future. It looks pretty promising. So 1.3 should feature semantic network access controls based on labeling. Runtime security of containers getting better all the time. User namespaces, default seccomp policies are two really good examples of that on the runtime side. The stuff that the CoreOS guys are working on is all terrific for security. So a lot to worry about here, but the important thing is to be honest about the actual security posture of these systems, and to be aware of what trade-offs and what you're going to need to do coming down the line. This here is a picture of a columbine flower from where I live in Colorado. Columbines are very special. They only bloom for about a week in June. They're gorgeous, but they're incredibly delicate, a lot like etcd. So etcd being the beating heart of Kubernetes, without it, nothing survives. And yet it's incredibly difficult to operate. Like any CP data store, requires lots of care and feeding to ensure that quorum is maintained. please do not go into production with a 3-node etcd cluster. Don't do it. We see this all the time, and it kills me. Folks will stand up this 3-node cluster, separate it out in different AZs, thumbs up, and then the minute they need to perform maintenance on one of the nodes, they take one member out of the quorum, and now if they lose one other member, their etcd cluster is dead in the water, right? And that's really, really bad. So, and they're staring down the edge of the abyss at that point. So if you're serious about uptime, you're going to want a minimum of 5 nodes in your etcd cluster, so you can perform maintenance while still having one node, available, to have an outage. And guess what? It turns out maintenance windows are actually correlate pretty well with when you have outages, because we tend to fat finger stuff, right? So, so even more important. High availability. etcd isn't the only place where availability comes into play. The entire Kubernetes control plane should be HA, but you're not going to know until you pull the plugs. So have a failure mode, spreadsheet and test plan. Automate it if you can, but you really test this out and prove it before you get in there, because you're not going to be able to replicate all the failure modes, but having a baseline is critical to keeping your job, probably. So. Eventually, shit's going to hit the fan, right? It's going to happen. You're going to have something resembling total cluster failure, not a matter of if, but when and how. And you think, oh, self-healing distributed systems, but you need to plan for these catastrophic failures. How do you spin up a new cluster from zero? How do you back up and restore a cluster configuration and get those workloads running again? How do you recover data that might have been tied to those workloads? Make sure you have solid answers to these questions. If you want to sleep at night, you're going to rehearse this DR process regularly. Step 5, final phase here. At this point, we've been in production for a while. Excitement has died down a bit. Things are humming along. Work is not yet done, though. Most organizations who are at the size where they need Kubernetes are also going to have a lot of other workloads that could be running on the cluster, but aren't yet. Right? And it's important that you sell the benefits of Kubernetes to other teams and other engineers inside your org. This is how you make the cluster self-sustaining, how you reduce the bus factor for the folks who are working on it. So some things we've seen work in the wild. Generate an internal case study that describes before and after Kubernetes and how awesome that transition can be. Parachute some Kubernetes experts into software teams inside your org and make sure that they're successful with their first forays. Getting management on your side. Way to do that is management speak, right? KPIs, key performance indicators. Measure them before and after. You do that, management's gonna love you, right? The last thing you want to see is a Kubernetes cluster that works brilliantly and then languishes and dies from lack of use and lack of organizational buy-in. So don't let that happen. You gotta sell this thing inside once you stand it up. And lastly, inevitably, you can't force people to use a system like Kubernetes. We advise our customers to stand up a cluster and leave it running alongside whatever legacy pipelines exist today. If folks want to do things the old way, let them do that. Developers are already up to their ears in new tech. You don't want to be force-feeding them things like Kubernetes. So take your time, plan out a thoughtful adoption strategy that includes a thorough evaluation, document your processes discovered during dev tests and as you move into production, demonstrate some real wins in production, and by doing that, you can win over your peers, and workloads are eventually going to migrate over to Kubernetes organically. Thank you, everyone. Great. At this point, questions? Yeah, thanks.
So we have about 10 minutes for questions.
No questions. First person to ask a question gets a t-shirt. Yeah, you get a t-shirt.
I'm not removing mine. So.
Hi, I got a question. Say we have in our company 5 different systems, completely separated, and basically one of was warehousing solution, second one was analytics, yada, yada, yada. They're completely not integrated, but right now, because of some business decisions, we decided to integrate them. And there is talk about building some kind of common platform for managing the whole infrastructure and the code deployment and stuff like that. How would you approach this kind of situation? Would you rather do it piecemeal, like one system and then the second one and then the third one and so on? Or rather, would you approach it like, okay, we got to figure out how all of the components are going to be working together when we're going to manage them with Kubernetes or maybe something else?
Yeah, so it's a good question, and a lot of this gets down to the specifics of the workloads that you're talking about, but, one of the things that I generally recommend is, once you have some of these legacy systems in place, you've already invested in a deployment pipeline, and it's really painful to rip all that up and just redo it. But one pattern that we're starting to see emerge as successful is people standing up Kubernetes and then using the service discovery and sort of the service and endpoints logic to actually map external services into Kubernetes without deploying them inside of Kubernetes. Having to, which is another way of saying Kubernetes becomes sort of the single source of truth for your environment. All services are registered there, whether legacy or not, and then you can slowly start moving services into Kubernetes, which may over time include legacy services. Things like pet sets are coming in Kubernetes, which are going to make it easier to move legacy stuff in. But generally, you're going to want to move the references to those services before you move the services themselves. So that's what I'd say. Yeah. Other questions?
In your experience working with the customers that you guys have at Deis, what have you guys found to be the most difficult part of deploying a Kubernetes cluster and deploying Kubernetes as a concept within a company? Is it?
I have a really, really straightforward answer to that. Everywhere we go, we stand up a Kubernetes cluster for a customer, and then they pull in some representative from the software group or one of the software groups, and they go, replication controller, like a Kubernetes service, like what are these things? Like IRM, I'm up to my ears in Maven, and you're trying to bring all this really crazy amount of conceptual overhead and ask my developers to learn it. Having to expose all of Kubernetes to software developers is just like a no-win thing. It's really, really difficult to do. Inside Google, you go through like a 6-week Borg training class. Most folks don't have the bandwidth to do that. So Deis Workflow is sort of our 12-factor PaaS that sits on top of Kubernetes. You get the benefits of the engine, but you get the Git push workflow and a lot of the stuff that developers are commonly it's a lot easier for them to understand. So a lot of the tooling, frankly, that we build at Deis, things like Helm, things like Deis Workflow, are designed to solve this problem of deer in the headlights from a software team looking at Kubernetes. Other questions?
We were just talking about the challenges of getting the developers to know the Kubernetes platform. You built Deis for exactly that, but have you had some consulting where you actually had invested in the process to actually train the developers on the platform?
Yeah, so this is a funny thing. So I mentioned this in the beginning of the talk. People associate Deis with PaaS, right? And we do have a great PaaS, but we do a ton of Kubernetes only work. I would argue that more than 50% of what we do today is at the Kubernetes layer. Yeah, we bring in things like Helm and our edge routing, but we don't actually end up deploying the full-blown PaaS everywhere. So a lot of people don't want that, right? They want to have tight control over their pipelines. A way that I like to look at it is if the linchpin ends up being the commissioning and decommissioning of services. If you want developers to have control over creating a new service and bringing that into existence and then managing it in production, then you want developer self-service, and the PaaS stuff is probably for you. If you want the creation of a new service to go through an operations vetting process and a CI pipeline stand-up and something like that, you probably don't want a PaaS, or you want to keep the PaaS isolated into in a dev environment. So we do both, but we do a ton of work at just purely the Kubernetes layer. We also offer, if you didn't know, we're actually one of the only vendors, I believe, who does this. We sell support for the underlying cluster manager for Kubernetes. So, one of the things we find is, as people move towards that, that cloud-native operational model I mentioned before, a lot of operations, a lot of the value that operations people will provide inside an org is there's more value to be provided at the workload level, right? Kubernetes cluster operations and support is sort of undifferentiated heavy lifting. We actually offer that as a service. We have a 40-person global support team, thanks to Engine Yard, who's our, who acquired Deis back last year. We provide the support for lots of vendors and lots of companies running on top of Kubernetes. So interesting. If you're looking to get out of doing Kubernetes upgrades, we offer a solution for that. Yes, question up here? You may maybe shout. Oh, he's coming.
We have time for one more question, probably.
Thanks for your talk. So my question is, what operation system can you recommend? I mean, CoreOS obviously, but anything else?
So we work with any operating system. I think that I'm at CoreOS Fest for a reason. We have been big believers in it, and we think it's the best way to run Kubernetes, and I think that a lot of people are finding that to be true. So I definitely personally recommend CoreOS, but the whole part of the idea with Kubernetes is that it shouldn't be dependent on the OS.
Last question, anyone?
Questions? Okay. I'll be around after if you have any other questions or you're shy. Come find me afterward, and I'll also be over at the Deis booth if you want to see a demo. All right. Thanks, everyone.